Hello everybody. Today we are going to be taking a look at this new problem. This problem is specifically going to be talking about trees. We did graphs earlier, and trees is a similar concept, but it's a little bit simpler if I'm being honest. But let's just take a look at this problem and take a look at what it's asking. So the problem is called kth smallest element of a BST, and a BST, a binary search tree. I'll give you the definition of the binary search tree in a second. We'll first go through the problem. Given a binary search tree and an integer k, find the kth smallest element. Note there are two arguments in the input. First one is the root of the BST, and the second one is an integer k. Return an integer, the kth smallest element of the BST. And then they're given a bunch of constraints. So to start off, let's define what a BST is. A BST is essentially a tree. A tree is a format similar to a graph where you're given a bunch of nodes connected by edges. And specifically, a binary search tree is a specific type of tree where each node is connected to up to two nodes. And let's say this one is not necessarily each one has to connect to two nodes, but up to two nodes. And the format is that every node to the left of the left subtree of a node is less than the right subtree of the node. So for example, let's start by building a sample tree here. So we can start with the number 5, and let's say we want to input another number, let's say 3. Let's say we want to input the number 7 into the tree. This one is greater than 5, so it would have to be greater and putting to the right. If we want to input the number 2 into this tree, it would be less than 5, so you'd go left. But since 2 is less than 3, you'd go left again. If you wanted to input 4, you'd go left. 4 is less than 5. 4 is greater than 3, so it would go onto the right side. If we want to input the number 8, you'd go all the way down here because you keep going right. And if you want to input the number 1, you'd want to go all the way down here. Alright, so as you can see, basically in the binary search tree, every left subtree, which is the section of the subtree that is to the left of a node, every left subtree of a node is less than that node, and every right subtree of the node is greater than that node. So for example, 5, every element in the right subtree is greater, and every element to the left is less. Same thing with 3. Every element to the left of 3 is less, and everything to the right of 3 is more. And that's essentially what a binary search tree is. Now, knowing that, how do we find the kth smallest element? So if you just look at the binary search tree, how would you go about doing this? The best way to go about doing this is to go using what is called an in-order traversal. So an in-order traversal starts at the smallest node. What is the smallest node in this tree? It's going to be 1. And as you notice, it's the leftmost node. So you start by finding the smallest node and then basically doing an in-order traversal to travel up. So what an in-order traversal would look like was it would be going to 1 to 2, and 2 to 3, and 3 to 4, and then 4 to 5. Well, it can't go directly there. It would have to go back to 3, but it would skip 3 since it's already added, and then it would go to 5, and then it would go to 7, and we'd go to 8. So that's the route that we'd have to basically take to go through every single node. So that's what's called an in-order traversal of a binary search tree, and that is what we kind of want to do. And because essentially once we do that in-order traversal, we'd only need to traverse k number of times. If we're trying to find the kth smallest element, we'd have to travel k times. So for example, if k in this case was 3, all you'd have to do is go to 1, 2, 3, and then it would output the number 3. Alright, so let's take a look on how to do that in code. How would we do an in-order traversal in code? Alright, so I set up the first class, which is the tree node. A tree, the node is defined by self and then value of, the default value is going to be 0 that we can set up. Left is equal to none, right is equal to none. Self.val and then self.left to traverse left, because there's going to be to traverse to the left node, and self.right to traverse to a right node. So this is the essentially the tree node and how that would look like in Python. And here is our kth smallest function. Now it's taking the root as an input, which is a tree node, and the number, the kth element that you're trying to find in the binary search tree, the kth smallest element. So to do an in-order traversal, it is a type of depth-first search, which we kind of covered back in graphs. You can review that video of how that would work. And to do a depth-first search, we always want to use a stack. So in Python, a stack can be as simple as defining it through a list. We're going to set an element to say we're going to use the element current, which is defined as the root variable. So this is what we're going to be using to define through to perform the depth first search in the traversal. Alright, now essentially what we want to do is start by in an in-order traversal. If you guys remember, the first step is to go all the way to the left. So 5, 3, 2, 1. So all the way to the left. To do that, all we need to do is make a simple while loop. So we'll say while true stack dot append current is equal to current dot left. And yeah, wait, sorry, not just while true, while current. The reason we want to do while current is if we just continuously do current dot left, eventually we'll get to current being none, because once it's on the edge of the tree, and you try to go left from the edge of the tree, it'll be none, and then it'll give a none point exception if you try to do none dot left. So essentially, once current becomes none, it'll stop, and we know that right now current is going to be the leftmost node after this little loop here. Now that we're on the left, we've gotten to the leftmost node, and we've added all the elements that we previously traversed through in the stack already. Now all we gotta do is start going back. Current is equal to stack.pop. This will return will take out of the loop the first element that we visited, and then we'll go k minus equals to 1. Remember, k is the element that we're trying to find, the kth smallest element. So for example, if k is 1, all we would need to do is stack.pop and k decrement k, and once k is equal to 0, all we need to know is that whatever we just popped, that's the one that we need to return. So return current dot val. So you keep doing that, like you'd return the current dot value. But what happens if obviously there's a chance that the current dot value we popped, the k is not 0, like k minus equals to 1, then all we need to do is start traversing back right. So current is equal to current dot right. Because as you guys remember, once you reach this left node, you pop out the first element that you put into the stack, in this case 5, and then traverse up. So in this case up would just be right. Yeah, you can't see it super well here, but this is traversing right. So then it'll go right, pop out a value in the stack, see if we're on the k element, if k is equal to 0. Otherwise, we keep traversing right. So we go right, 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 and then in this case, when you're trying to go back, it wouldn't go back because you'd already have popped the current element. However, it'll just keep going right, 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 right. Shoot, sorry for closing that, but essentially, yeah, that's how the code works. And we could do some quick setup here. So I'm going to quickly copy and paste this setup that I have for creating the tree so we could test this code real quick. So the tree would look something like this. If you remember previously how we created the tree by keeping the root as 5 and then 3 and then 7 and then 2, 4, 1, 8. This is essentially the tree that we just created with this code right here. Yeah. So now if we're trying to find the third smallest element, we'll set k is equal to 3, and then let's print out kth smallest of root, comma, 3. So now if you remember, based off of the code, the third smallest element in this list should be 3. So when we look at the code, it should return 3 if we did everything right. And there we go, it returned 3. So let's say we want to find the first smallest element. We could just test that base case just to get everything clear. Sorry, I meant to put k here so that we could actually test the code once we change this variable. If k was 1, we should return 1 because 1 is the smallest element in the list. It'll return 1. How about if we want to find the largest element in the list? How many nodes are there? 1, 2, 3, 4, 5, 6, 7. If we want to find the 7th smallest element, which is in fact the largest element, we could do that and it will return 8 because 8 is the largest one. And yeah, we could test it one more time with like one more example. What if we want to do like let's get to the root node, how do we get to the root node? The root node is the 1, 2, 3, 4, 5, literally the 5th smallest element. We could test that and we'd get to 5. So yeah, our code essentially works, and we successfully used a proper in-order traversal depth first search to get the kth smallest element. So hope you guys understood everything, and I'll see you guys in the next one. See ya.